Alright, so for this video, I'm going to do a really quick physics problem, and it's about a coefficient of friction and a turntable, and it uses a bunch of concepts you learn when you do circular motion. And then it recalls on the fact when you learn forces. What does it mean for something not to move? In this case, not moving, but it's staying in a circular path. Stop right now. So they give you a coefficient of static friction and how fast a turntable is moving, and a coin is on the turntable, and you want to solve what is the maximum distance from the center for which the coin will stay in circular motion and not slide. So it's going to look like you have some turntable, you have a coin, and it's going to have some distance r, and you want to find the maximum r. And once you do that, it's going to move in a circular path. In this case, omega is clockwise because positive. I'm assuming clockwise positive. Okay. So, and the big key thing is when things are in circular motion, there's centripetal acceleration, and that's the only thing that matters when in terms of what's going to keep in circular motion. So in this case, it said not slide. So that's a big hint that friction is going to be the force that's going to keep it in circular motion, which is what that force is going to be doing. So that force is going to be equal to the centripetal force. So what does that mean? You're going to have some force. It's called centripetal is equal to static friction force, and you want to find the R. So when you're doing these, you're not going to know what R is, and you're not going to know what mass is because they don't give it to you. And it turns out you don't even need it. So how do you go about that? Well, in this case, first off, it starts from here. Normal force of a coin on a turntable. That's just the mass of the coin times gravity. And then static is related to normal force by it's the coefficient of static friction times normal force, which is going to be giving you the maximum force of friction. In this case, so I'll just do this. So that's what you need to know for that. But in this case, you also have to know the centripetal force. And you know they're equal, but you don't know what this is yet. But how do you relate circular motion? Well, you basically have to remember it, but centripetal force is the mass of the thing moving in that motion times acceleration. But acceleration isn't equal to the tangential velocity of and the r of its orbit or motion, whatever. In this case, it's this r. Okay, so that is going to be equal to c. And the big problem, I guess, is you don't know what v is explicitly because you don't know what r is. And you'd be able to find it because you know what w is. So if you knew r's, you could find what v is. The whole point of this problem is you don't know r's. So, you know, one thing you also have to recall is that w, or omega, or our angular speed, is related to tangential speed. If it's moving in a circle, in this case it's that. So if you just want to plug what this relation is into there, that's what you're going to have to use. So if you do it, what do you get? So I'm going to come set these guys equal and plug in the real interpretation of V, what we're going to want, into this guy. And what do you get? You get coefficient of static friction times normal force, which is mass of the coin. It's gravity. For the mass of the coin times v squared, but in this case r times omega and square it, so you get omega squared times r squared all over r. Turns out you don't need to know the mass of the coin, which is why they don't even give it to you. And this gives away. So then you're left with the maximum r you get is just equal to static friction times gravity over omega squared. But because they give you numbers, I'm going to tell you what that number is. But in this case, also, it's revolutions per minute. Don't like that. So you get 3.3 per minute. I want radians per second to make the units okay. You get 1 rev is equal to 2 pi radians, and 1 minute is equal to 60 seconds. That's going to give me radians per second. And that's a number. Let's call it number A. So, ends up being, when we solve this, you get 0.30. G, I'm going to choose to be 9.8 meters per second squared. Doesn't matter because I know all my other units are okay. That's the big thing. If I didn't do this, if I just plugged in W, it wouldn't be okay. I'd have to make sure that the units are okay. So it's going to be number A squared. And that's equal to, I believe I did it and I've done it a bunch of times. I believe it's this, and I wrote it on the last one. I wrote it on, it has to be 1, it came in 2 because it was 1, 7. Alright. So big thing to remember, if it's things are in circular motion, something has to be keeping in circular motion. In this case, it's friction. That's why I use this guy. And you had to recall, centripetal force is the mass times centripetal acceleration. And the frictional force you have to recall is related to normal force and the coefficient of the static friction. Or it could be kinetic friction, but that wouldn't be for this case. Alright, I'm gonna stop there.